Okay, well, thank you very much indeed for what I found an absolutely fascinating talk, reminiscing to the past and some predictions of the future. So I'm sure you have lots of questions.
Richard Moore from IBM. I'd like to thank you for showing pictures of the BBC Micro. A day isn't complete for me without a round of Chucky Egg. I still have my BBC Micro. I still switch it on at least once a year, and I still use an emulator for it. Now, my serious point is this. The BBC Micro, I look upon as being a seminal thing for me in building my career. I work for IBM, and I work on development of, a part of the development team for the mainframe processor. Now, the one thing that it did, and you didn't mention, was it made the link between the software and the electronics. It was a fantastic platform to learn about digital electronics because it was not miniaturized to the point where it was impractical to play with this and experiment with it. And what I wonder is that ever going to be available to school children again, or is digital electronics lost to them?
We have a project, Raspberry Pi, that hopes to be the next BBC Micro, and I think the first number of units that we have ordered was 2,000 units because we thought it would be popular. And one of the things that it shares with the BBC Micro is that we got the numbers wrong, because we now have 350,000 orders for Raspberry Pi. So I'm very excited about that. It costs £26. It comes as a bare board, actually. So you really know what it's all about. You can understand it because it's simple enough. You plug in a standard keyboard. It's got an HDMI output, so you plug in your TV set a la BBC Micro, but now with a slightly better resolution. It's got an Ethernet connection, and it doesn't even come with a power supply, because there are standard micro USB power supplies for all mobile phones, and it doesn't need any more than a mobile phone power supply. So I'm very excited about that. I'm also very excited about some initiatives that people are thinking about in terms of making really low-cost, simple-to-use robots. Because I think we want to have this hands-on experience that people can program a robot and maybe with 3D printing also make parts for it so that they can use the robots not just for making them walk around and do a little dance or something, but do something useful by creating special arms maybe to do a special job. So I very much hope that Raspberry Pi in particular, which is a very clear initiative, will make an impact.
Peter Newman from Artificial Learning Group. We're on the trying to be on the front end of the brainwave and build the hardware to actually achieve that 100,000-fold improvement in efficiency. But we're concerned about applications. One of the things you talked through in the architectures from the mainframe onwards was a continuity of application. And so this old software tended to run on new hardware. But when we go to neuromorphic computing, that won't be the case. So how do we create a market for the brainwave?
I think the market is right there in the user interface, because computers are still so stupid when it comes to interacting with humans. We've got to adjust our behavior towards the computer. We've got to use a keyboard, or we've got to use things that aren't actually the way we interact with other humans. But to provide the human interface for a computer, I think will benefit enormously from neuromorphic computing. One thing that I forgot in my sort of what next slide is really the importance of probability variables. That one of the key things that came out of the seminar that I talked about is how fundamental Bayesian inference, probability variables. There's a wonderful paper by Sebastian Thrun, who runs the Google Car project, where he defined an extension to C++ with a probability data type, and reports that his students that were asked to program a mail robot at his Stanford lab could do so 10 to 100 times faster just because of this new data type. So I think the world is moving towards you.
Herman, that was an excellent talk. Thank you again. I read an interesting article, which I'm sure you will have seen too, and many other people recently, in The Economist, I think it was, a few weeks back, which compared and contrasted the business models of ARM and Intel. And in the light of your anecdote about, or your story really, about Dell and the hollowing out of Dell, I wonder if you could explain how you think it's possible to continue in the medium to longer term retaining the, I suppose essentially the IPR in a company like ARM, and prevent it sort of leaking away and being reproduced by other companies around the world.
Well, when I mentioned the IBM mainframe, I also mentioned the lock-in that was associated with DASTI and COBOL and Fortran and all of the good things that they had. And as long as there was the mainframe business, IBM had a wonderful position. It was very interesting to hear from you that, of course, and I should have mentioned it, that although mainframe isn't the main computing platform that most people use, the mainframe business itself hasn't disappeared. In fact, it's still growing, I believe. So it's very interesting to see. Now, what has happened around ARM, and that is very exciting, is that the processor itself could be replicated, and of course Intel can do with the Atom, eventually we'll get there to a lower power consumption version, although they're not quite there yet. What they do not have, though, is the ecosystem around it. So it's the ecosystem of lots of different instantiations of the ARM. So whichever ARM you want, there's now a continuous range of ARMs from a very low power, very low cost, right up to gigahertz, 2 gigahertz, I think is the latest one. Very high performance with graphics and all the additional things, all done by ARM licensees. And there, of course, is now a complete stack of things that you do in mobile phones, which all runs on the ARM. So all the protocol stacks, the apps, the compilers, all the stuff that is associated with the ecosystem gives ARM a certain robustness in its business model. The other reason why I have continued excitement about the future of ARM is ARM has just brought out the Cortex M0. The Cortex M0 is a 20-cent microprocessor. It makes no sense for anybody else to come out with a 20-cent microprocessor because you can't make any money with it. But if you license it to people and they put it into their Internet of Things, it makes a lot of sense for them. And as long as the numbers are high enough, and it has to be billions to make any sense, and the only company that can really expect to sell billions of something is ARM. So the future, is very difficult to make predictions, especially about the future, as you know. So I don't know how this is going to pan out in the long term, but right now I think we remain to be in pretty good shape.
My name's David Cairns. I don't have an affiliation because I'm a decade and a half older than the stored program computer. You've had on the screen and very briefly mentioned the cloud, but you haven't really expounded that. Is it a passing phase? Is it essential to the mobile phone world, or what? What is the role of the cloud?
Oh, it's absolutely essential to the mobile phone world, because the only reason why smartphones are so smart is because they can get at the information that is stored in the cloud. And the other reason why I didn't mention it is that it's still dominated by Intel, of course, because all the servers run Intel. Interestingly, if you look at the main problem that people have building these big data centers, it is actually not the performance of the microprocessors, it is power consumption. they actually had to build major power stations next to these big data centers. And that, if you talk to any of them, this is their number one concern. And delightfully, there are some startups that use the ARM architecture, which is intrinsically lower power, to produce servers that are 10 times more power efficient in the server space than Intel. So watch this space.
I know there are lots of questions, but time has defeated us. Herman will be around afterwards for those of you staying, so perhaps you can direct your questions to him afterwards. I would now like to call Anthony Finkelstein to give the vote of thanks.
Well, good evening, ladies and gentlemen. It's with that delicate sense of irony for which the BCS is so well known that I've been asked to give the vote of thanks this evening, and ironical about exactly how. Well, the first is, to ask a London professor to thank a speaker so well known for investing in Cambridge. Well, here I simply observe that when Dr. Hauser had to make a really important investment, he made it at UCL in the education of his own daughter. And of course, there's a further irony, which is that that's to ask a software engineer to propose a vote of thanks after a talk on computer architectures. Well, it's actually not that ironical, because us software engineers, we're fairly used to following on from the hardware architects. Hence the current situation where we have 1 core to do processing and 15 to do virus checking. But on a more serious note, and without the ironical tinge that my own presence here invokes, I'd like to thank the speaker for really a most interesting and stimulating talk. I personally suspect that the future is very much bound up by the intimate integration of software and hardware architecture. Indeed, what I think the last question about the cloud precisely alludes to is that it is software architectural innovation in harmony with hardware architectural innovation that actually will drive future developments in our subject. And it is precisely that intimate integration, the intimate integration which you've achieved, for example, between investment and innovation, which is what drove the Cambridge phenomenon, which I think is called for. So, without keeping people from their food and drink, I will just wish to propose that the thanks of the BCS are accorded to our speaker, Dr. Herman Hauser.
Okay, thank you very much indeed, everyone. It is the tradition at the close of the BCS Lovelace lecture that we announce the following year's winner. In 2012, the award was given for contribution to engineering, which, such as inventing methodologies and other forms of applied research. And I'm sure it will come as no surprise for you to hear that the recipient of the Lovelace Award for 2012 is Grady Booch. Clearly a worthy winner, and I hope very much that you will return next year to hear his talk. That concludes the formal part of the evening, and for those of you who've booked, please do come to the reception afterwards, and I'm sure you can continue the discussion with Herman Hauser. Thank you very much. Well done,